Hi, everybody. We are in week one of semester two, and this week we are going to start statistics. So, this is our first lecture on statistics. So, I'm going to divide this lecture into 4 parts so that you can have breaks in between. So, during the break, you can do some problems on the worksheet, or you can sip a cup of coffee or tea. It's all up to you. Yeah, you can organize your time. And this is going to be your first part, yeah, part one. Okay, so we're going to start by introducing ourselves to statistics. So we'll try to answer questions like what is statistics, why do you need statistics, and how will it be useful in your chosen degree course. So before we start, I'm going to put a question to you guys. First question to you: what is statistics? Please type in your answer in simple English, just in few words, and this is not graded. Okay, just type in few English. Excellent, guys. Very good. Statistics is the science and art of learning a sample from data. That is, statistics is the science of drawing conclusion about the world from data. Okay, so it involves collecting or recording the data, representing the data in a graphical way, like bar graph, line graph, pie chart, yeah. Representing the data in graphical way that you would have already done using Excel, yeah. So you would have used simple icons, simple tools like pie chart, scatter diagram, or line graph, yeah. These simple icons you would have used to draw your graphs, isn't it? So what else could be the best way to represent the data than representing it in a graphical way? Yeah. And then finally, once you collect and record the data, you represent the data in the graphical way, and then you study, analyze, and interpret the data. That's what we're going to see in semester two. You're going to see different tools you're going to use to represent the data and analyze and interpret it. Okay, because this allows quantitative reasoning required for making important advancement in science. Okay, so in simple words, in biology and chemistry, it is all about collecting experimental data, reviewing it, and representing it in a graphical way. Then you study it or analyze it, and finally interpret it quantitatively to predict the future and make important advancement in science. Yeah. Okay, what do you see here? Some statistics. Can see some statistics here. Yeah. You might have heard this, that you can clearly distinguish between an American actor and a British actor. Yeah. By just looking at the teeth. Ironically, that's true. The Hollywood actors like to have white, polished, and shiny teeth, while the British actors prefer a more natural look. Yeah. So having bad teeth is one of the biggest American jokes about British people. But what really matters, I think, is the dental health. So look at this, how much decay is there? So they have studied uh, a few 12-year-old children, and what have they seen? Look at the statistics here. About 0.6% of 12-year-old children are affected by decayed, missing, or filled teeth in UK, while there are 1.2% of the children affected in America. Almost double the percentage. So clearly, this makes you thinking, isn't it? This could be due to reasons like dental hygiene. Yeah. So statistical studies are carried out to answer questions like how often do we visit the dentist? So you can see here that 7 out of 10 in UK visit dentist, while 4 in 10 visits a dentist in US. So such statistics are very useful for us because these studies are very important for dentists, because once the dentist use this data, they come to a conclusion, they draw a conclusion from that. Yeah. So such statistics are used by your local dentist to encourage dental hygiene in the community. What do? They collect the data, analyze the data, interpret the data, which is then used to support the community to help us have better dental hygiene, because these clearly shows that maybe the number of children in UK there are more number of children in UK who brush their teeth when compared to the children in America. Yeah. So anyway, when you visit a dentist, you always see such statistical charts on the wall. Yeah. And what do? They just give you or boost your confidence to brush your teeth and take care of your dental hygiene, isn't it? So indirectly, dentists are helping us to keep our teeth, keep our dental hygiene, and which affects our dental health, isn't it? So statistics are useful. Yeah. So not only dentists, there are others also who use statistics, or I should say everybody uses statistics here, isn't it? So anyone involved in science, medicine, dentistry, agriculture, psychology, and in any other area will need a basic understanding of statistics. Yeah. So actually, I'm also teaching business students statistics, how you can use statistics for business. So statistics is there everywhere. Yeah. Everybody uses statistics in general. Yeah. So now data. What is this data? Okay, let's consider us, just us. Okay. So let's take us. Among us, we are all different. Yeah. Each individual is different because each of us have our own characteristic feature. We are all different from each other. Yeah. There is some variation between us. Yeah. So there exists a variability between the animals, the group of animals there, the plants. Each plant is different from probably, so you collect data, and organisms. Yeah. So why do we need statistics? Why? Because within any given population, there exists variability. Okay. So now, can you think of an example of variability? Good. Statistics provides the tools that enable us to measure and manage the variability that exists naturally in data so that we can better understand the population. Okay, let me take another good example. We can use statistics in predicting diseases. Now look at this chart here. What can you see here? You can see that the darker shade, this is causes of lung cancer death due to smoking, while the lighter shade is the causes of lung cancer death due to some other reasons. Yeah, lung cancer death can be due to any reason. Yeah, so what can you see here? 90% of lung cancer deaths in men and 80% in women are caused from smoking. See? Yeah. And people who smoke are 10 to 20 times more likely to die from lung cancer, isn't it? So statistics helps us to get some information here. Yeah. So it helps us to interpret the situation. As you can see, we can interpret that the more cigarettes smoked and the longer a person smokes increases risk for lung cancer. Statistics helps us to draw conclusions that smoking is injurious to health. Yes, quitting smoking will decrease the risk for lung cancer. So important conclusions can be drawn from statistics like this. So you collect data and you find the number of lung cancer death due to smoking and non-smoking, and you come to a conclusion. So when you interpret, you come to a conclusion which is useful for the community. Yeah. So statistics is important in predicting diseases. Let's take another good example. In drugs and medical studies, how statistics can be used. Before any drug can be prescribed, the valid rate of its effectiveness is proved statistically. Can you think of a good example here? The current situation, COVID-19 vaccine. Yes, we are in a situation, isn't it, where vaccination took such a long time to come in handy. And still, only few countries have started giving vaccination. Yeah. So it's all after undergoing several clinical trials, isn't it? And statistics has now helped us to draw a conclusion that Moderna and Pfizer vaccine are the most effective vaccine. So we can come to a conclusion of the effectiveness of a vaccine statistically, isn't it? So we are seeing that now. This is the current situation is a beautiful example of statistics, how statistics helps us in general. Yes, the whole world is in need of statistics now. Yeah. Okay, so that is what more can be a good example for statistics now. Yeah. So statistics is used in every medical study you hear about. I don't want to miss another good example. Okay, genetics. Okay, we use genetics. Yeah, you would have started genetics probably. Few diseases are passed to their children genetically. You know that. Yeah. So statistics are critical in determining the chances of a new baby being affected by a certain disease. Good example, cystic fibrosis. Yes. Do you remember what it is? Yeah. So cystic fibrosis is a hereditary disorder. Most of you would have heard that. Yeah. It affects the 7th chromosome in a gene. Yeah. It is an autosomal recessive genetic disorder, isn't it? So it is characterized by lung congestion and infection and malabsorption of nutrients by the pancreas. So this is one good example of statistics. You know why? Let's see, quickly we'll go through this, yeah? So let's consider D is the normal gene and small d is the defective gene, okay? So if we have an unaffected carrier father and an unaffected carrier mother, and if we cross them, that is a carrier and a carrier father and a mother, what do we get? We get one normal baby, two carrier babies, and one affected baby. And what do we conclude from this? We use statistics and we come to a conclusion. We draw a conclusion that 1 in 4 babies will be affected between a cross between a carrier father and a mother. Yeah. So there is 1 in 4 chances that the baby is going to be a cystic fibrosis affected child. Yeah. So there is 1 in 4 chances that the baby is going to be affected. So that's probability, that is statistics, yeah? So statistics is used to determine what are the chances of a new baby being affected by a certain disease. So statistics is used in genetics also. Now over to you. Now, can you give me an example of how you could be using statistics in your chosen field of study? Excellent. So use of statistics. So we have seen today in the part 1, the use of statistics in your chosen degree. Thank you. What are you going to do in the second part?